Electricity, energy that is put to work in many ways on today's AMC cars and Jeep vehicles. Where does this electricity come from? There must be an electrical source. The source is the battery, and this release, the third in our continuing series of basic electrical training programs, will cover what you need to know about batteries. Starting with the 1978 model year, AMC cars and Jeep vehicles are equipped with a battery which greatly reduces normal battery maintenance. This battery can make your job easier. First, however, you should know about battery operation. This will help you diagnose causes of battery problems. You should also know about battery construction. This will help you understand why the new battery requires less maintenance than older types. And most important, you should know about battery safety, battery service, and battery testing. This will help you use the correct procedures when working with the new battery. Let's look at battery operation. The battery is often thought of as a storage tank for electricity. This is not true. Instead, the battery holds chemicals which can produce electricity. These chemicals are held in cells, or small compartments inside the battery. Here's a very simple cell. Two different pieces of metal suspended in a chemical. One metal has a positive electrical charge, the other a negative electrical charge. The chemical reacts with the different metals, and electricity wants to flow from one metal to the other. If you connect a lamp between the two metals, electricity will light it. But when most of the metal has reacted, the chemical will be used up, and the cell won't be able to produce any more electricity. A cell in an automotive battery works the same way. The positive material is made of brown-colored lead peroxide. The negative material is made of gray-colored sponge lead. The chemical is a mixture of water and sulfuric acid. It is called electrolyte. This electrolyte reacts with the positive and negative materials to produce electricity. In automotive batteries, active material is pasted on a grid to make a large plate. Several plates are then welded together with a plate strap to form a plate group. The plate strap has a terminal for making electrical connections. Each cell has one positive plate group and one negative plate group. The positive and negative plates are alternated. Separators act as electrical insulation and keep the plates apart. The complete assembly is called a cell element. It includes two plate groups, the separators, the connecting straps, and two terminals. The element is placed in a case containing the electrolyte. When the electrolyte reacts with the plates, about 2.2 volts of electricity is produced. The battery voltage depends on the number of cells. AMC cars and Jeep vehicles use 12-volt batteries. To get about 12 volts, 6 cells are connected in series using cell connectors. The battery current capability depends on the plate surface area in a plate group. A battery with large plates or many plates will have more plate area than one with small plates or few plates. It will produce more current per element. A battery with a large plate area will crank a larger engine. When a load is connected to the battery terminals, current begins flowing as the electrolyte reacts with the plates. This forms lead sulfate on the positive and negative plates and changes some of the electrolyte acid into water. This is called battery discharging. The plates become chemically similar and lose their different charges. They need to be different to produce electricity. The reaction stops when the electrolyte becomes diluted with water and lead sulfate coats the plates. This coating is called sulfation. With normal discharging, it may be like a light frosting, but when the battery is not properly maintained, it may be as hard as concrete. Charging can remove light coatings of sulfation, but not hard coatings. The battery is automatically charged by the vehicle's charging system when the engine is running. The charging voltage must be greater than the battery voltage to reverse the chemical reaction. Then, the sulfate comes off the plates and turns some of the water back into acid. The plate materials return to their original form. Batteries that are extremely cold or severely discharged will take longer to be charged. Large plates cannot be charged as quickly as small plates, and impurities, such as dirt in the electrolyte, will slow down charging. Gassing is the other factor that increases resistance to charging. No matter how much electrolyte is in the battery, gassing occurs during charging when the electrolyte nears full strength. Hydrogen gas bubbles form at the negative plates, and oxygen gas bubbles form at the positive plates. These gases bubble out of the water in the electrolyte, washing active material off the plates and causing a loss of water. This lowers the electrolyte level, increases the acid strength, and may expose a portion of the plates. In normal operation, batteries will need the addition of distilled water to replace water lost to gassing. If the sulfate on the plates is exposed, it will harden and becomes impossible to remove by charging. Distilled water is recommended to prevent impurities from getting into the electrolyte. Hard sulfation and impurities may cover up part of the active materials. When the plate surface area available for reaction becomes small, charging cannot restore the battery. Such a sulfated battery requires replacement. How a battery is built affects its maintenance and useful life. Our new battery for AMC cars and Jeep vehicles is built for a longer life with less maintenance. The case is tough, yet lightweight, polypropylene plastic. Not heavy like the old hard rubber case. This thin wall container has more room inside for more energy-producing material, and that means longer life. Another power-producing improvement is the use of through-the-partition cell connectors. The new cell connectors send the electricity to the terminal posts over the shortest path possible. Possibly the best improvement is in the plates themselves. Old batteries used a grid made of lead and antimony to support the active materials. The antimony made the grid strong, but it also helped cause gassing. Our new battery uses only half as much antimony in the plate grids without any loss of strength. This reduces the gassing, which washes away active material and causes water losses. The battery lasts longer, and the electrolyte needs to be checked only once every 15,000 miles. Maybe only at the start of winter, but more often only in hot climates. Another important change is more electrolyte above the plates. Instead of adding more electrolyte, like is done in some batteries, the elements are placed lower in the case. This provides the benefits of less frequent water addition without increasing the chance of spills. All of these improvements add up to better performance and less maintenance. But the basic operation of the battery is the same. You will still use many of the same safety, service, and testing procedures for trouble diagnosis. Whenever you work around a battery, safety should be your first concern. The electrolyte contains sulfuric acid. It can eat your clothes. It can burn your skin. It can cause blindness if it gets into your eyes. If you ever get electrolyte on your skin or in your eyes, wash it away with large amounts of water and get medical attention. Electrolyte gassing may form an explosive gas near the battery, even though the strip-type caps seek to prevent this. Any spark or flame can ignite the gas and turn the battery into a potential bomb. Here are some general safety tips to keep in mind when testing or servicing a battery. Wear gloves and safety glasses. Remove rings and wristwatches. Don't use power tools that produce sparks. When activating a dry charge battery, avoid acid spills that can get in your eyes or on your skin, the car finish, or your clothing. And when jump-starting a dead battery, follow the recommended service procedures. As mentioned, the service procedures on the new battery are much the same as with the old. The big difference is the longer service interval for checking the electrolyte level. Start your service on any battery with a visual inspection. This may reveal simple problems which can be quickly corrected. It can also reveal problems which might require battery replacement. Check for cracks in the battery case. Check for broken or corroded terminals. Check for damaged cables or cable connections. Check for a loose battery hold down. Also, check for a loose alternator drive belt. Next, check the electrolyte level in the battery cells. You will have to pry off both cell covers using a wide blade tool such as a putty knife. A thin blade, such as that on a screwdriver, will damage the covers. Insert the blade along the cover edge and twist it. The cap will pop up and you can lift it off. Looking into each cell opening, you should see a distorted surface if the electrolyte level is okay. You should see a smooth reflecting surface if the electrolyte level is low. If necessary, add distilled water to each low cell until the electrolyte reaches the bottom of the well. Do not fill the well to the top. The electrolyte will spill over when the battery is charged, and the loss of acid will shorten battery life. Water is lighter weight than acid. In fact, the acid is almost twice as heavy as water. So when you add water, it will float on top of the acid instead of mixing. The water and acid must be mixed, or the battery will not work properly. Running the engine will charge the battery and mix the water and acid. But to be safe, the battery should be connected to a battery charger and charged at 20 amps or less until all cells are gassing freely. You will see bubbles in the electrolyte when the gassing occurs. To use the charger, first disconnect the battery ground cable. This will prevent possible damage to the alternator. Next, connect the charger, positive cable to positive post, negative cable to negative post. Then turn on the charger and adjust the charging rate to 20 amps or less. Other types of battery service you may have to provide include cleaning the battery case and cover, jump-starting a dead battery, and activating a dry charge battery. The battery can be cleaned using a brush and a diluted solution of ammonia or soda. Make sure you don't get any of this wash solution into the battery. A dead battery can be jump-started with a portable starting unit or a booster battery. The correct procedure for safe jump-starting is in your film reference booklet. One jumper is connected to the positive post of the dead battery, then to the positive post of the booster battery. The other jumper cable is connected to the negative post of the booster battery, then to a bolt, bracket, or nut on the engine with the dead battery. Do not connect it to the negative post of the dead battery. You may cause a dangerous spark. Sometimes you will have to replace a battery. Replacement batteries for AMC cars and Jeep vehicles are supplied without electrolyte. They are called dry charge batteries. Original equipment batteries have electrolyte and are called wet charge. You will have to add electrolyte to activate the replacement battery. Before you start, carefully read the instructions and warning on the electrolyte carton. Also, do not remove the vent seals until you're ready to activate the battery. To activate the battery, fill each cell with electrolyte to the bottom of the vent well. Next, gently tilt the battery from side to side to release any air trapped between the plates. If needed, add more electrolyte. Finish the job by installing the cell covers and charging the battery at 20 amps or less until all cells are gassing freely. Regular battery service will normally ensure excellent battery performance. The battery will be in good condition to start the engine, its most demanding job. Testing is the only sure way to determine the battery's condition. The battery usually requires testing for one of three reasons. 1. The alternator is overcharging the battery. 2. The alternator is undercharging the battery. And 3. The engine will not crank, even though a visual inspection corrected any problems with cable connections and with electrolyte level. With normal driving and temperatures, the battery should use only a few ounces of water every 15,000 miles. If the battery seems to use an excessive amount of water, this may indicate that the battery is being overcharged. Such overcharging washes active material from the plates, and the heat involved can warp the plates. Testing can reveal damaged cells. Sometimes, however, a faulty charging system will not maintain the battery at full charge. This undercharging allows the sulfate on the plates to become hard and impossible to remove by proper charging. With less acid, the weak electrolyte can freeze much easier, and the undercharged battery may fail to crank the engine, especially in cold weather. If the engine will not crank, or if you suspect an overcharging or undercharging problem, there are two basic tests you can perform: a specific gravity test and a heavy load test. The specific gravity test determines the chemical condition or charge of the battery. It can tell you if the battery is worn out or damaged. Most important, if the battery is charged enough for the heavy load test. The heavy load test determines the electrical condition of the battery. It can tell you if the battery is capable of cranking the engine. The specific gravity test measures the exact weight of the electrolyte. It compares the electrolyte's weight with that of water. Strong electrolyte in a charged battery is heavier than weak electrolyte in a discharged battery. The electrolyte in a fully charged battery has about 36% acid and 64% water. The water has a specific gravity of 1. The acid is 1.835 times heavier than water, so its specific gravity is 1.835. The mixture of water and acid has a specific gravity of 1.270. The specific gravity of electrolyte is measured with a hydrometer. This is a float or bobber that is weighted on the bottom so that it will stand up when floating on a liquid. The electrolyte level must be okay before a hydrometer can be used. If the level is low, you should add water and then charge the battery until the cells are gassing freely. This mixes the water and acid. Otherwise, your hydrometer will draw up only the water just added, and the hydrometer readings will be wrong. To perform a specific gravity test, start with the first cell at the positive end of the battery. Insert the hydrometer tube into the electrolyte. Then squeeze and release the hydrometer bulb to draw up enough electrolyte to raise the float. Do not remove the tube from the cell, and read the specific gravity at eye level. Once you've taken the reading, squeeze the bulb to release the electrolyte. Use this procedure on all of the battery cells and record your readings. Hot electrolyte is lighter than cold electrolyte. However, hydrometers will read accurately only at 80 degrees Fahrenheit. These hydrometers will sometimes have a thermometer, and you will have to figure a temperature compensated reading. For every 10 degrees difference, 4 points, or 0.004, should be added to or subtracted from your readings to obtain the temperature compensated readings. For instance, if the electrolyte temperature is 95 degrees, you would add 6 points, or 0.006, to the reading. If the electrolyte temperature is only 60 degrees, you would subtract 8 points, or 0.008, from the reading. Some hydrometers will do the calculations for you. They will have a thermometer that shows how many points to add or subtract, or they will have a dial that shows the corrected reading. When you have the correct specific gravity, you can determine the condition of each cell. Your film reference booklet details what various hydrometer readings can tell you. If the specific gravity reading of one or more cells is less than 1.235, the battery should be charged. Charge the battery at a rate of approximately 5 amperes. Continue charging until the specific gravity readings for each cell are constant for 3 consecutive hours, or until the battery is gassing freely. When the specific gravity readings, either initially or after charging, are above 1.235, it indicates a near full charge. But if a 50-point difference exists between one or more cells, the battery is not serviceable and should be replaced. If the specific gravity readings are above 1.235 for each cell, and there is less than a 50-point difference between each cell, you can perform a heavy load test on the battery. A heavy load test is sometimes called a capacity test. It measures the capacity of the battery to produce enough power for starting as well as ignition. To perform this test, you use a tester which has an ammeter, a voltmeter, and a carbon pile. The carbon pile provides an adjustable resistance to simulate the load of the starter on the battery. The ammeter is connected in series with the pile and battery. The voltmeter measures the battery voltage output during the test. First, clean the battery posts and cable connections to ensure good contact. With the carbon pile turned off, connect the tester leads. Then load the battery by turning on the carbon pile. This loading will show up as an amount of current flowing from the battery. The correct amount of current, as well as the complete test procedure, is given in your film reference booklet. After the battery has been loaded for 15 seconds, read the battery voltage. If it is 9.6 volts or higher, the battery is okay. It has good output capacity. If the voltage under load is less than 9.6 volts, the battery is not okay and should be replaced. It has poor output capacity. These battery tests, for specific gravity and for heavy load, should reveal any battery problems which may be preventing the engine from cranking. If you correct battery problems, or if the battery tests okay and the engine still will not crank, the problem most likely is in the starter system and not in the battery. This completes what you should know about battery operation, construction, safety, service, and testing. You should now be prepared to use the correct procedures when working with the new battery on AMC cars and Jeep vehicles. Together with your film reference booklet, technical service manuals, and technical service bulletins, this film can help you make sure the source is ready to do its job.